We know that the graph of a quadratic equation changes when we change the coefficients of the variable or the constant term associated with it. But without actually plotting the graph, can we figure out what kind of transformations will take place in it? Well, short answer, yes. Long answer, you'll have to watch the video. So come on, let's nail it. Alright, so we are going to talk about quadratic equations today and their transformations. Well, you could call them quadratic equations or quadratic polynomials or quadratic functions. They are known by several names. And for today's lesson, let us start with the simplest of quadratic equations, which is f of x. F of x stands for a function of x. So f of x is equal to x square. Well, probably you would already be knowing what the graph of this looks like, but very quickly let's plot a graph and see what it looks like. So let's take a Cartesian plane. These are my axes and let's do the marking here. And then I'm going to make two columns. So let me take x and f of x. So let me take some values for x and f of x. So when x is equal to 0, 0 squared becomes 0. So f of x is 0. If we take x as 1, then 1 squared is going to be 1 again. So f of x is 1. If we take x as 2, then 2 squared is 4. So f of x is 4. Let me take some negative values also. So if we have x as negative 1, then negative 1 squared is also 1. So f of x is 1. If we take x as negative 2, then the square of that is positive 4. So f of x again is 4. And if we mark these points on the graph, I've got 0, 0, which is the origin, which is the point here. I've got 1, 1, which is here. I've got 2, 4, which is here. I've got negative 1, 1, so 1 unit to the left and 1 unit up, which is here. And negative 2, 4, so 2 units to the left and 4 units up. And when I join these points together, it looks like this. So this is a sort of a curve. Well, not a very neat graph, but still delivers the point. This kind of a graph is called a parabola. And this is a parabola opening upwards. And we'll see what kind of transformations will this go through if we change anything in the quadratic equation. So let's take this as the parent function and we'll compare each graph to the graph of x squared to figure out what the transformations will be. And to get a general idea what the graph looks like, let's look at a neater diagram. So the graph of f of x is equal to x squared looks something like this. Now let us very quickly mark the points also on this graph. So we had 0, 0, which was the origin. We had 1, 1, which is here. We had negative 1, 1, which is here. We had 2, 4, which is here, and negative 2, 4, which is here. Well, before we actually go into the transformations, I would like to remind you that if this is the first time that you are coming to this channel, and if you're a student of mathematics, you must consider subscribing to the channel because a lot of useful information is available waiting for you here. And do not forget to click the subscribe button at the bottom of the video, and also do not forget to click on the bell notification because that will ensure that each and every future upload is sent right into your inbox. Now let's figure out what happens to the quadratic function when we add some number to it. So for example, let us take this time f of x is equal to x squared plus 2. So this time I'm going to take 3 columns here. Let me take it as x, x squared, and then f of x, which is x squared plus 2. And let us start with the same values of x that we had taken earlier. So it's 0, 1, 2, negative 1 and negative 2. And obviously it will have the same values of x squared also, which is 0, 1, 4, 1 and 4. Now to figure out the value of f of x, all we have to do is just take the value of x squared and add 2 to it. So the values that I get is 0 plus 2 becomes 2, 1 plus 2 becomes 3, 4 plus 2 becomes 6, 1 plus 2 becomes 3 and 4 plus 2 becomes 6 again. And if we look at the graph of this quadratic function, it would look something like this. And let us very quickly mark the points also on the graph. So we have 0, 2, which is right here. We had 1, 3, which is here. We also had negative 1, 3, which will be right here. We had 2, 6, which would be here, and negative 2, 6, which would be here. Well, what do we see in this graph? all we see is that the vertex of the parabola or the bottommost point of the parabola has shifted 2 units up, and not only the vertex but each point on the x-axis has now shifted 2 units upwards. Let's have a look at another quadratic function, which is f of x is equal to x squared minus 4. Now again, all we have to do is just subtract 4 from the values of x squared that we had. So 0 minus 4 is going to give me negative 4, 1 minus 4 is going to give me negative 3, 4 minus 4 is going to give me 0, again 1 minus 4 negative 3, and 4 minus 4 0. And the graph of this function would then look something like this. And if we mark the points, we have got 0 comma negative 4, which will be right here. We have got 1 comma negative 3, which is here, negative 1 comma negative 3, which is here, 4 comma 0, which will be on the x-axis on this side, and negative 4 comma 0 again on the x-axis but on the other side. So again, if you look at the graph carefully, what has happened is that the vertex from the original function x squared has just moved downwards by 4 units, and not only the vertex but each x point on the graph has gone down by 4 units. So in short, what we can say is that if we have got a function which is x squared minus k, where k could be any number, then the graph is just going to move downwards by k units. And if it happens to be x squared plus k, then it is going to move up by k units. So this is called a vertical shift in the graph. So that means whenever we add a number to x squared, which could be a positive number or a negative number, the graph is just going to go up or come down depending on whether k is positive or negative. But what about the quadratic function if f of x is equal to x plus 2 whole squared? So this time you see that the 2 is not being added outside the square, it is being added inside the square function. So this time I'm again going to start with 3 columns. So I'll have my x value, then the second column would be x plus 2, where we are adding 2 to the value of x. So if we take x as 0, then x plus 2 would then become 0 plus 2, which is 2. And then to find the value of f of x or x plus 2 whole squared, it will be the square of 2, which will be 4. Now let us try and have a look at it a little differently. Why not take those values of x plus 2 whole squared which we had taken earlier for x squared? So we had taken 0 for that. So if x plus 2 whole squared is 0, then obviously x plus 2 is also going to be 0. And if x plus 2 is equal to 0, we can then take 2 to the other side. So that gives me the value of x as negative 2. The same way, if I take x plus 2 as 1, then 1 minus 2 will give me a value of negative 1 for x, and the square of 1 is going to give me 1. If we take x plus 2 as negative 1, then obviously the value of x, we subtract 2 more from that, so we get the value of x as negative 3. So negative 3 plus 2 gives me negative 1, and the square of negative 1 gives me 1. And if we want to take x plus 2 as negative 2, then again we subtract 2 to get the value of x, which is negative 4, and negative 4 plus 2 gives me negative 2, and the square of that gives me 4. And the graph of this quadratic function would then look something like this. So again, let's mark our points very quickly. So we had 0, 4, which was here. We had negative 2, 0, which will be right here. We had negative 4, 4, which will be here. We had negative 1, 1, which will be this point, and negative 3, 1, which will be this point. So what has happened to the graph here? Well, if we look at the vertex, the graph has shifted 2 units to the left, and not only the vertex but each point on the x-axis has now shifted 2 units to the left. Well, that looks kind of confusing, doesn't it? That we had added a number to x and the graph is shifting leftwards, whereas in coordinate geometry, whenever we add something, it goes to the right. Well, yes, it is kind of confusing, because in k it wasn't so confusing, because whenever we were adding, the graph was moving up. Whenever we were subtracting, the graph was moving down. Well, but why not look at it this way, that if we are taking the graph of x plus 2, we have to shift it right to get it back to the original position. So if we are adding a number, we are going to shift the graph to the right, but actually the original graph will shift leftward. Now for the next quadratic function, let's take the function as f of x is equal to x minus 4 whole squared. So this time we are subtracting a number from x, not adding it. Again, let me take the same three columns that we had taken earlier: x, x minus 4, and f of x, or the square of x minus 4. And let's take the same values of x that we had taken earlier. So x we had taken as 0, 1, 2, -1, and -2. And this time we are subtracting 4, so we want x minus 4 to have the same values. So if x minus 4 is equal to 0, then x is equal to 4. That means we are adding 4 to 0 to get it the same value. And then obviously the square of 0 is going to be 0. Let me write the other values also. 1, the square of 1 is 1. 2, the square of 2 is 4. -1, the square of -1 is 1. And -2, the square of that is 4. And now we are going to add 4 to each of these values. So 1 plus 4 becomes 5. 2 plus 4 becomes 6. -1 plus 4 becomes 3. And -2 plus 4 becomes 2. And the graph of this function would then become something like this. Now again, marking the points, we had 4, 0, which will be here, the vertex of the parabola. We had 2, 4, which will be this point here. 6, 4 will be this point. 3, 1 will be this point. And 5, 1 will be this point. Well, so that brings us to the conclusion that whenever we are subtracting a number h from x and square it, then the graph is going to move h units to the right. And same way, if we are adding h to x and then squaring it, the graph is going to move a little to the left, actually h units to the left. So this kind of a movement is called a horizontal shift. So you can remember it this way, that h stands for horizontal, because as you see, not only the vertex but each point on the x-axis has now moved right by 4 units. Well, what is going to happen if we have the function as f of x is equal to -x squared? Well, so let's find the points first. Again, I'm going to take 3 columns: x, x squared, and f of x, which is -x squared. So we had 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4. Well, and for the values of f of x, we are going to multiply each of these by -1. So we have got 0, -1, -4, -1, and -4 again. And if we plot this graph on a Cartesian plane, it's going to look something like this. Well, this looks like a reflection of the original x squared graph, and it has actually reflected vertically. That means it has reflected along the x-axis. So you could also call this a vertical reflection or a reflection over the x-axis. It's almost like we had a mirror here on the x-axis and the graph is just being reflected over the x-axis. Well, let's look at this quadratic function now. F of x is equal to x minus 2 whole squared. So how should we plot the graph? We know that it is x minus 2 and it is inside the square function. So the vertex of the graph is going to shift 2 units to the right. So from the origin, 2 units to the right would be on the x-axis here. So this should be the vertex. And then the point 1, 1 that we had, that also will shift 2 units to the right. So that will become 3, 1. And the other point, which was -1, 1, will again shift 2 units to the right, which will come at 1, 1. So the graph should go somewhere from here. And if we actually plot the graph, yes, it does go from there and it looks something like this. Now let us take another function, which is g of x, which is not x minus 2 whole squared, but it is minus x minus 2 whole squared. So all we have done is we have added a negative sign in front of x. And if we were to mark the points, if we take x as 0, then 0 minus 2, the square of that is 4. So the point would be 0, 4. Then if we take x as -2, so negative of -2 becomes +2 and 2 minus 2 becomes 0. So the point that we will have is -2, 0. Then again taking x as -3, so negative and negative becomes positive and 3 minus 2 is 1. So the square of 1 is 1, so that becomes -3, 1, which will be this point here. Taking x as -1, so negative of -1 is +1, 1 minus 2 is -1, and the square of that is 1. So it's going to be -1, 1. And taking x as negative 4, negative 4 becomes positive 4, 4 minus 2 is 2, and the square of that is 4, so it's going to be negative 4 comma 4. So if we look at the vertex of this graph or the axis of symmetry, it's going to be this line here, which is nothing but x is equal to 2. And if we look at the axis of symmetry of this graph, then it is x is equal to negative 2. Now this time it almost looks as the graph has reflected itself over the y-axis. So it's almost like placing a mirror on the y-axis and the graph just shows a mirror image of itself. So in conclusion, we can say that whenever the sign of x is negative but inside the square function, we are going to have a horizontal reflection or a reflection over the y-axis. Well, what happens if we take the function f of x as 2x squared? So again, let me start with 3 columns: x, x squared, and f of x, which is 2x squared. Let me start with the same values of x and x squared, which is 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. So this time I'm just going to multiply 2 to each of these values. So I get 0, 2, 8, 2, and 8. And if we look at the graph of this function, it looks something like this. Well, so it looks like the graph has become narrower now. So it looks as if it's growing faster. And if we delete all this and take the function as 3x squared, then we are going to multiply all these values by 3. So that gives me 0, 3, 12, 3, and 12, and the graph of that is going to look something like this blue curve, which has even become more narrower. Well, so that means the larger the value we multiply by x squared, the narrower the graph will become. But what if we take a smaller value? Why not take f of x as 0.5x squared? In that case, we are going to multiply each of these values by 0.5, so we get 0, 0.5, 2, 0.5, and 2, and the graph of that looks like this orange curve here. Well, this looks like it has become wider this time. What if we reduce the number even further? Let's take f of x as 0.25x squared. So in those cases, the values would be 0, 0.25, 1, 0.25, and 1, and the graph of that would be something like this purple curve, which has now become more wider. Well, so that brings us to the conclusion that if we multiply x squared by a number a, we could have several scenarios. Like if a is greater than 1, then we have seen that the graph becomes narrower. But a could be less than 1 also. So if it is less than 1 but greater than 0, then we saw that it became wider. Same way, if a were to be negative, that means less than 0, but at the same time greater than negative 1, then again the graph is going to be wider. And in the scenario that a is even lesser than negative 1, then the graph is going to become narrower. But in both these cases, since the coefficient of x square has now become negative, therefore we will also have a reflection over the y-axis, or a vertical reflection. Well, so we could have a quadratic equation in the form f of x is equal to a times x minus h whole square plus k. Now we can have several scenarios in front of us that k could be positive or it could be negative, h could be positive or it could be negative, and the same way a could be positive or it could be negative. So we know that when k was positive, we saw that the graph moved up, so it is going to move up by k units. If k is negative, then the graph is going to move down by k units. In the case of h, it was showing us a slightly different scenario where it was showing us the opposite of what we expected it to do. So that is why I've changed the sign of h here and taken it as x minus h. So that means when h is positive, it will give me x minus h, which means the graph will shift to the right. And if h is negative, then it is going to give me x minus of minus h, which becomes positive. So the graph is going to be shifted to the left. Well, I kind of goofed up here, so don't pay attention to what I've written. But when h is positive, it is going to shift to the right, and when h is negative, it's going to shift to the left. And when a was positive, we had two more scenarios in front of us, that either it could be greater than 1, in which case the graph became narrower, or it could have been less than 1, in which case the graph became wider. And again, in the case of -1, it could be greater than -1, in which case the graph became wider, or it could be less than -1, in which case it would become narrower. But in both these cases where a is negative, we will have a vertical reflection over the x-axis. Well, we could have two more scenarios. What if a was equal to -1? Well, if it was equal to -1, it would just show a vertical reflection. It would neither be narrower nor wider. It would be the same graph but reflected vertically. And the last scenario, if a is equal to 1, then there will be absolutely no change in the graph. It will be the same. So once we have seen the general form, we can then work out on an example. So what if the function that we have is f of x is equal to 2 times x plus 1 whole squared minus 3. Well, so let's start looking at the transformations one by one. We have -3 here. That means k has a value of -3, which means it will shift the vertex and the complete graph 3 units down. 1 is being added here. That means h is equal to -1. That is why it has become positive. So when h is -1, the graph is going to shift 1 unit to the left. And because 2 is being multiplied to the squared function, that means it will have a stretch. It will become narrower by a scale factor of 2. But if a or this number had been less than 1 but greater than 0, then it would have been called a shrink. Now, what do you think would be the transformations in a function like f of x is equal to x squared minus 7x plus 2?
Well, stumped you, didn't I? Yeah, it's kind of confusing because this we haven't done so far.
But we are going to do it, and for that you'll have to click on this video on the right, and do not forget to click on my picture on the left, because that is going to subscribe you to the channel. And do not forget to watch these videos also, because they are going to be very useful for you. And as far as transformations or quadratic functions are concerned, congratulations, you've nailed it. Take care. God bless.